Okay, good evening or good afternoon. I'm going to take about 25 or so minutes, maybe 30 minutes, to go through some ideas that are very, very big. And I encourage everyone to continue this discussion after the conference is over, and continue this after you leave this experience today by doing the research and a lot of the original writings that you're being introduced to.
What's your name?
My name is Matthew. Hi, everybody. As we've seen from the previous presentations, there comes points in human history where we encounter pregnant moments, moments where the ideas that organize the society into a certain direction confront reality, where reality starts pressing upon the conceptions that we've been allowing ourselves as a species governed by free will to either obey or not obey. So there's a certain reality, and if our ideas are not in harmony with that reality will come creeping up on us in the form of an unnecessary war, and the realization that we haven't been producing what we needed to produce to sustain our population, and we have a collapse, in the form of banking meltdowns where people start worshiping money, thinking that that's the source of value and power and wealth instead of something more profound and more real. And we've seen this historically, right? Where folly drives a people to obey ideas that they should otherwise know are wrong, to the point that they pay the piper. You have a collapse of civilization. You have banking collapses. You have unnecessary wars. And the question is, do we have the wits to foresee into the future the consequences of bad ideas, wrong ideas, and change them through a process of deliberation, wisdom, courage, before our children pay the effects? And we're sitting today, as we all know, on the biggest bubble, financial bubble in history. We're sitting on the verge of a major war between NATO powers and countries that want to have a future, like Russia, China, and their allies. And this is not the first time. However, this is the first time that this has happened on such a large scale, and the first time that we've had atomic weapons peppered all over the earth. I'm going to introduce something which has been touched upon in previous presentations, by looking at somebody who Mr. LaRouche has cited on many an occasion as being a key figure in this battle towards liberating mankind from the folly of self-destruction, who is a leading scientist, somebody who most North Americans don't even know, and yet who is a national hero in Russia, a leading member of the Russian Academy of Science, as is Mr. Lyndon LaRouche himself, who is a member of the Russian Academy of Science. But this man was named Vladimir Ivanovich Vernadsky. And Vladimir Ivanovich Vernadsky is a man who is known to be the founder of a field of study called biogeochemistry, but he's much more than that. He's an individual who was born during the American Civil War in Russia, in St. Petersburg. He had died right at the end of World War II. So he lived through a very turbulent period of history. And just as we heard from Gilles, the fact that the American experience of the American Revolution or the American Civil War were not American experiences. There are certain battles that happened geographically expressing themselves in the form of the United States, but they were globally extended processes, right? The American Revolution was not supposed to be something that ended in America. It was supposed to be a process that overturned the idea of the divine right of kings around the world that was supposed to be successfully replicated in France, Poland, Germany, and beyond, into Russia and everywhere else. With Lincoln, his allies immediately were invited and brought to Japan, to Russia, to Europe, to South America, to bring that system of Hamiltonian political economy to these countries so that they could fight for the first time British free trade, British monetarism, the idea that there are divine rights of a master class who have a certain body of rules that they are governed by, and that the rest of the masses, who have to remain poor and enslaved intellectually and physically, have a different set of rules. That idea had to be scrapped. And Vernadsky is the man we're going to look at both as a figure, as an individual, who we all have a right to know and must actually start mastering some of his concepts as we move into this new system that's being organized by the initiatives of the New Silk Road, space exploration, and everything we've heard today so far, which are founded upon certain principles of natural law. And all of the greatest scientists, I was always struck by, maybe you've noticed too, but the greatest scientists who made real paradigm-shifting discoveries were never just ivory tower scientists. These were people who were implicated politically in major battles, whose lives were sometimes taken, who were risking their lives, and getting their hands dirty in reality to apply their insights into natural law that they got, as Benjamin Franklin did through his studies of electromagnetic phenomenon, to making lives better for people, and in so doing, making better systems of law, better standards upon which we judge a law to be good or bad. Vernadsky was absolutely no different. So, this is as I said, his father, two of the key influences in Vernadsky's life as he was growing up in a world which was being swept by this internationalization of the Hamiltonian credit system of protective tariffs, state-directed productive credit working with national banks, internal improvements, scientific and technological progress. This idea was sweeping the world in the period of the late 19th century. Two of the most influential figures in Vernadsky's life were his father, a leading political scientist who had translated the works of Henry C. Carey and the other Hamiltonian thinkers in America into Russian and fought to apply them, as we saw with the manifestation of the Philadelphia-produced trains that went to Russia to build the Trans-Siberian railroads. But also Dmitry Mendeleev, his friend, his professor, his mentor, who had come to the United States for quite some time to study that American system and brought it back in his role as the chair of the Committee on the Protective Tariff in Russia. Mendeleev, everyone here knows Mendeleev, right? The founder, the discoverer of the periodic table of chemistry, right? This man not only made a revolution in our understanding of what unifying principles organize the atomic spectrum that's produced in the cosmos, in stars, and found a unifying principle, but he also fought to recognize that it was by looking at the geography, where do these minerals and elements occur on land in a nation, that we can then organize a nation to escape the bondage of an agrarian society which is not productive, which is always going to be submissive to manipulations or economic warfare and dismemberment, which has always been the tools of empire. And Mendeleev headed the Committee on the Protective Tariff to bring this to Russia and fight off British free trade in the defense of the Trans-Siberian Rail and industrialization. His student was Vladimir Vernadsky. Vernadsky himself, just to get this across, applied this when he was a professor in the St. Petersburg Academy of Science, and founded, during 1905, during the core beginning of the revolution, he founded a political party called the Constitutional Democrats, a leading opposition party. This man was risking his life at every step of the game. He founded the Ukrainian Academy of Science at a certain point in 1919. He founded and was the director of the Committee on Productive Forces. This is a major organization in 1915 that was created in order to figure out, to take Mendeleev's work further, to start actually not only mapping out, but then tapping into those resources and other deposits that were located in the vast territory of Russia, so that the Russians could not only fight off Germany and other countries in World War I, but to create a condition where you could pull people out of, brute force manual labor, which is something which the whole population had been largely subjected to for much of Russia's history, because you needed to have an ability to process those materials. I can't use a ton of iron ore that's in front of me. I can't use coal. I can't use a mineral unless I have some means of processing it and converting it into something useful. So it's that power of machinery, of machine tool design. This is a reflection, a shadow of thoughts, concepts that have to improve in order for us to refine our ability to mediate what nature has there, that we're born into a world which has certain things in it. We have to not only figure out how do we start using those things, but how do we apply those things to make life better for people. So his commitment was not only to be, he was facing a world that was shaping his thinking, but he decided to take the challenge of shaping that world in return. And this founded the basis of his lifelong work to found a new field of study called biogeochemistry. And he realized that the problems of mankind were largely, that were plaguing man, were because of the fact that we misdefined what the universe is, what the mind is, what human nature is. And to the degree that we tolerated, an imperial definition of mankind as being something to be manipulated by a master class, then we would always be subjected to these cyclical collapses. And he said, well, look, we have to redefine the problem, we have to look at the context. Biology, nor chemistry, nor physics, nor geology occurs separately. All of them are fields, but that interconnect. The reason why we have mineral deposits is largely on the Earth is because you have hundreds of millions of years of life, producing, and areas where you have iron deposits. This is produced largely because of certain types of bacterial formations over time, utilizing iron, concentrating in certain areas, and then over time you have the buildup of certain deposits. You don't seem to have those things in places like the moon, where there isn't much of a presence of life, as we now know. You have a much more dispersed form of atomic spectrum on the Earth's surface. On the moon surface. On the Earth's surface, you have it much more concentrated in areas where you can actually access it. The very existence of our ozone layer could not exist were it not for the appearance of certain forms of living technology like photosynthesis, the chlorophyll molecule that could produce free oxygen in a way that allowed it to accumulate, that thus had a certain effect upon how life could then evolve in an environment by limiting a certain amount of the ultraviolet light and X-ray light that would otherwise be very destructive. You wouldn't want to live on a world with no ozone layer. But the ozone layer couldn't exist were it not for the development of certain type of biological creations like photosynthesis. So he saw that there was an interconnectedness, and he said, let's on the one hand, create a new field of study, and let's observe as well that all of the observable and discoverable, meaning discovered and not yet discovered forms of existence, atomic existence, energetic and atomic, exist either in one of three forms. Either it exists in the form where it's animated by life, in which case we'll have the biosphere, where you have atoms that are not animated by life, right? Walk around, you see some rocks, concrete's another thing, rocks. There's carbon in them, there's carbon in the plant, but it's not the same carbon because it's not animated by the same action, the same principle. So you have the abiosphere, or the lithosphere, atoms not organized by life. You have the living domain of the biosphere and its effects. And then you have something else, a higher domain, which Vernadsky helped shape and helped define in a way that even today is not fully appreciated. Vernadsky wrote that the biosphere constitutes a definite geological envelope sharply differentiated from all other geological envelopes of our planet. This is so not only because the biosphere is populated by living matter, having enormous significance as a geological force, completely reworking the biosphere and transforming its physical, chemical, and mechanical properties. In addition, this is the sole envelope of the planet, penetrated in an appreciable way by cosmic energy, which transforms it even more than living matter does. The main source of this energy is the sun. The sun's energy, thermal, light, and chemical energy, is, together with the energy of the chemical elements, the primary source for the creation of living matter. So what do you have when you look at the biosphere is the fact that you have a phenomenon which directly is being driven in all of its cycles, right? The growth of the new seasons, the growth of new species every year. You have a certain cyclical, constant motion of energy and atoms constantly taking in and energy from the sun and from the galaxy as a whole into a thin envelope, as he defines it, as cosmic in nature. So he says you can't just look at the biosphere as a sum total of living things. You have to take the broader scope of space to see that this has an environment unto itself as well, which is cosmic in its nature. It has a certain geometry to it. And when you start looking at things from that broader standpoint, you realize that, well, not only do we have a certain spectrum of living things in one system of time, but these things didn't always exist. 99.9% of the species that have existed don't exist anymore. So then we have to confront the question, what is really the biosphere as a process of change? Are there any discoverable mechanisms organizing its directionality? Does it have a directionality, or is it all random? Right? These are basic fundamental questions which we can only ask if we take a proper context. in our mind, a unified context to start looking at the problem. And indeed, when you start looking not only spatially at the broader picture, but you could also begin looking temporally. You could take instead of looking at the biosphere in a small sliver of time of the past decades, years, or even centuries, but take a broader step back and look at, the last 500 million years that we have observed that there has been some form of living principle organizing atomic behavior on the surface of the Earth. And we have now, all of a sudden, something which is not so chaotic. We thought, a lot of people think of the biosphere as being somewhat of a chaotic thing, that living species are always constantly coming and going, but there's no generative principle causing it. But here we see, have you all heard of the big extinction cycles? Well, this is something which in recent decades has been increasingly uncovered, is that there are, in the course of the ups and downs of living species, not only do you not tend to get slow, gradual changes from one species to another, but you tend to get mass extinctions, as we see with the Permian-Triassic period, where you have a massive drop in species, or the Triassic-Jurassic, another massive drop of species. In this area, you had about 90% of all of the life in water disappeared through different factors, some which we don't really fully understand by far, but we know that it's periodic, that there's certain 60 million year and 140 million year cycles which we've been able to discover exist, where whole systems are transformed. Massive species die, and new species come into being as a system. So the whole system's character is more than the sum of its parts, is different in the new set that came about after an extinction versus what you had compared, if you compared it to what existed before. And again, we're doing this because there's a reason, there's a certain reasonable basis for organizing a political economic system according to principles that Alexander Hamilton, who Pim went through, and LaRouche have been talking about with his 4 laws. It's not just arbitrary opinion. There's a certain deeper reason for these things that are discoverable by anybody who's willing to conduct an inquiry into the facts. So we have now a periodicity of 60 million years being shown here. We also have a 140 million year cycle intertwined. Vernadsky makes the point that the mechanism is that we're going to look at that will determine what allows for one species to exist, or one system to exist and one system to go away, is located in a function known as the biogenic migration of atoms, where he writes, the biogenic migration is linked in the most intimate way and genetically to the matter of the living organism, to its existence. The organism lives as long as the current of, Cuvier gave a correct and precise definition of the living organism during its life as an incessant current, a whirlpool of atoms which come from the exterior and return there. The organism lives as long as the current of atoms subsists. Right, so we're constantly breathing in, eating, drinking, all sorts of atoms in different states of matter, and then it's leaving us in a different form, and you have a constant current. Obviously, when you die, that current no longer exists. Each organism on its own, or all organisms taken together as one system, continually create, by respiration, nutrition, internal metabolism, reproduction, a biogenic current of atoms which construct and maintain living matter. So, in looking at this, this is a simplified graph looking at these cycles, but this doesn't indicate that we have any direction. It just means that you have change. But this is, and if you just look at this graph, it would look like the change is being driven just by, things growing, collapsing, like any civilization historically grows, collapses. But this is actually not reality, because the reality, if you actually look at the evidence shown so far in the fossil records that we have access to, evidence is indicating that, in fact, you do have, just like in human civilizations, population growth. It seems like you have these growth and collapses. If you take a broader scope, you realize that the population is actually not going back to square one. We're not, every time you have a civilization collapse or a dark age, you don't just go back to the Stone Age. There's a certain basis upon which you have a growth function. But then again, how does the biogenic migration of atoms express itself in this growth function? And what Vernadsky zeroes in on is that he calls it one of his geochemical principles. The evolution of species leading to the creation of new stable living forms must move in the direction of an increasing of the biogenic migration of atoms in the biosphere. I'm sorry that I don't have enough time to really elaborate on this as much as I'd like, but we'll have to move through it and can pose questions maybe after the conference is over. One way of looking at this is that not only do you have a greater quantity of the overall organisms, but you also have a growth qualitatively, as we've seen that there's a certain ratio between lower metabolic rate organisms and higher ones that have a greater power of converting matter and energy into work over time. So we're going to look at some examples, about 4 of them, just to get a flavor. There's thousands of examples, though, that exist on our website and on other websites, which will give this more definition. So one example between there's something known as the PT extinction, one of those, the big extinction where I said 90% of the marine life disappeared. There's one example of 2 types of mollusks. One is called an articulated brachiopod. The other one is called the bivalve mollusk. Both of them have a very similar biogeochemical identity in the sense that both of them take in certain types of chemicals. They use certain types of foods. They have certain types of common predators. And they both serve a similar function in terms of what they do. You follow their behavior. However, one of them took a really big hit. This one, which was the dominant one of the 2, they both coexisted, but this one being dominant before this extinction cycle, completely took a hit and almost became, almost was wiped out. Whereas this one, the bivalve mollusk, just continued to grow and actually thrive, becoming the hegemonic one. What's the difference between the 2? They do the same thing. They're very similar, except that one of them has a metabolism which is about 10 times greater in its intensity than the articulated brachiopod. This one has to consume approximately 10 times more, but it has more of an efficient conversion of matter into energy to perform work than the one that took the big hit. An example of species, for example, mammals. We know mammals were relatively newer in their appearance in the biosphere than either reptiles or amphibians. Amphibians came much, much earlier. If you look at the food absorption in either a lizard or a mammal, you got 2 different relative functions, where one of them, if you look at your average reptile, this is not every reptile, but you have a 75 to 90% metabolism in terms of the food that's absorbed, that's not excreted. That means that food becomes energy that allows the organism to perform actions, which it needs to do. And about 10 to 25% become new biomass. So you have a constant turnover of cells in your body, of atoms that make you up are constantly changing. That is replenished in a much larger proportion than the mammal species, which on average only has about 1 to 3% becoming new biomass, replenishing dead cells, and about 97 to 99% becoming direct energy for heat for actions. This, as we know, gives animals an advantage whereby we have greater mobility, right? Greater ability to regulate internal heating, so you don't just die in the winter. You don't just you don't literally just stop moving when it's cold, as you have a problem with a crocodile in wintertime in Montreal. That thing's not going to last. But also there's certain other things that we're going to touch on. Not only was it the animal species, but you're dealing also with different types of plants. Gymnosperms are pine cone creating plants. Their capacity to photosynthesize, to do work, is much less than an angiosperm tree or anything which, like an apple tree or something that produces fruit. Energy-dense, carbohydrate-dense fruit is something which appeared much later on in the scene than the gymnosperm. And actually, they coexisted, but this was much, much more secondary in the biosphere than the gymnosperms, which were dominant before the Jurassic period ended, before you had the extinction of the dinosaurs. Vernadsky makes the point, it seems impossible for me, for several reasons, to speak of evolutionary theories without taking into account the fundamental question, this is Vernadsky, the fundamental question of the existence of a determined direction, invariable in the process of evolution in the course of all the geological epochs. Taken together, the annals of paleontology do not show the character of a chaotic upheaval, sometimes in one direction, sometimes in another, but of phenomena for which the development is carried out in a determined manner, always in the same direction, in that of the increasing of consciousness, of thought, and of the creation of forms augmenting the action of life on the ambient environment. So obviously there's always going to be, at every new species, even if the species is more efficient because they've developed a new biotechnology, whether photosynthesis, whether the ability to process calcium in the form of bones or what have you, that freedom comes with a boundary. So even though you escaped certain boundary conditions that existed in a previous system, you still have to face the fact that there won't just be 7 billion rabbits or monkeys or wolves on the planet anytime soon. They have certain limits that are caused by the fact that there's only so much food, that they're not going to develop agriculture. No matter how many beavers create dams, those dams are still going to be the same quality of dams as they were 5,000 years ago, as they will be 1,000 years from now if we don't have nuclear war. There's obviously a choice that humans can make to identify ourselves with our more animal-like characteristics and face those same animal-like boundary conditions, or do something which animals can't do, which is reevaluate how we define our identity and use something that the animals don't have that deals with self-conscious, as Vernadsky says, right? We have a power of consciousness, of thought, to create, and the creation of forms, augmenting the action of life on the ambient environment. So we can run away from that boundary condition and try to act small so that we don't touch nature and maybe just prolong the inevitable collapse, the heat death, you know, the fact that at some point we will have an asteroid and we just have to accept the fact that civilization is going to get hit like dinosaurs did and just try to like eke it out in, you know, little local control zones with not a lot of advanced technology, just a lot of bixies. Or we could run towards those boundary conditions by investing more in those things that will allow us to stop an asteroid. Things like, you know, you definitely need to have certain very high quality lasers, certain high quality forms of control of the atom to be able to deflect a massive asteroid coming at us. Which brings us to the question, desalinating water, greening deserts, right? How are you going to elevate people out of poverty forever? How can we break that extinction cycle is the big question. And Vernadsky made a point that we're now entering with this age of thought, the Nöosphere. This is the biosphere, abiosphere, no life, biosphere, life, Nöosphere. Atoms organized by cognitive thought. Which brings up the question, how does something immaterial, like thought, organize the material universe? Age-old problem. We're told, don't even bother posing the question, it's impossible, it gave Descartes a headache, it's going to give you a headache, don't try. Vernadsky wasn't that afraid. He said, look, there's a measurable effect between your ideas, if they're right, and how the universe responds when you act upon them to sustain more people at a greater quality of life with greater opportunities for dignity, self-perfection, creativity. And we see that increasingly the force of mind, this is a desert in Saudi Arabia, we have the application of electricity discovered by Benjamin Franklin, dams created by Roosevelt, the Egyptian pyramids. You have the mind organizing the universe in a way that's showing us fossils of concepts, of people's ideas of personalities. How much time do I have? Okay. 3 quotes. There exists still a third form in our epoch, says Vernadsky in a paper which you can read on our website. The Psychozoic epoch, an extraordinary importance in the history of our planet. It is the migration of atoms, also sustained by organisms, but which is not genetically or immediately related to the penetration or to the passage of atoms through their body. This migration is provoked by technological activity. It is, for example, determined by the work of burrowing animals, of which we notice the traces since the most ancient geological epochs, by the consequences of the social life of constructive animals, termites, ants, and beavers. But this form of the biogenic migration of chemical elements has taken on an extraordinary development since the appearance of civilized humanity, since tens of thousands of years ago. Entirely new bodies have been created in this way, as for example, metals in a free state. The face of the earth transforms itself and virgin nature disappears. Metals in a free state, I mean, he often refers to aluminum as one example of something which doesn't, metal aluminum as you get at the dollar store and you wrap your food in, doesn't occur in nature, you can't mine that. It looks more like a powder. You need certain applications of intense electromagnetic powers to start converting that into something you can use. So that type of example is one of many. The creation of isotopes that are transuranic that we could only create in particle accelerators. These are things that we don't necessarily just find in nature, but they're not unlawful either. They're not unorganic. They occupy a spot on the periodic table of elements. question, so what does that say about the nature of space, time, the nature of the mind that thinks about those things, that redefines its idea of space, time, and acts upon it, right? That can educate others to think on a higher level. Vernadsky takes it further. He says, the role of civilized humanity from the point of view of the biogenic migration of atoms was infinitely more important than that played by the other vertebrates. Here, for the first time in the history of the Earth, the biogenic migration, due to the development of the action of technology, was able to have a greater significance than the biogenic migration determined by the mass of living matter. All the same, the biogenic migration changed for all of the elements. The process was rapidly effected in a relatively insignificant amount of time. The face of the Earth has transformed itself in an unrecognizable way, and yet it is clear that the era of this transformation has only begun. Last quote. The historical process is being radically changed under our very eyes. He's writing this in 1943, in the middle of World War II, 2 years before he dies. And after seeing all of the misery of World War, he's still maintaining a very strong state of spirit and reasonable faith in a power of mankind that it's almost impossible to believe that somebody could have that faith and optimism in spite of all that they have been through. And this guy survived assassinations, or attempted assassinations in the time of the Red Scare, or Red Terror and beyond. The historical process is being radically changed under our very eyes. For the first time in the history of mankind, the interests of the masses on the one hand and the free thought of individuals on the other determine the course of life for mankind and provide standards for mere ideas of justice. Mankind taken as a whole is becoming a mighty geological force. There arises the problem of the reconstruction of the biosphere in the interests of freely thinking humanity as a single totality. This new state of the biosphere, which we approach without our noticing, is the Nöosphere. This new elemental geological process is taking place at a stormy time in the epoch of a destructive world war. But the important fact is that our democratic ideals are in tune with the elemental geological processes, with the law of nature, and with the Nöosphere. Therefore, we may face the future with confidence. It is in our hands. We will not let it go. So to recap, life is defined around a tendency towards increasing the flux of energy throughput of cosmic radiation from the universe, increasing its power to transform matter into energy to perform useful work, thoughtful work, self-conscious work, and that ultimately Vernadsky, this explains why Vernadsky was such a proponent and the father of the Russian atomic industry, Russian atomic energy sector. He not only saw this as the future, that if we're going to go beyond our limits into space, which he highly advocated, by the way, and he knew that we would end up becoming a galactic civilization, and he wrote about that, we would need to tap into the power of the atom. That to do this, we would have to have a more refined idea of justice, which has not been permitted to be hegemonic up until this point. But now we've come to a point where we have atomic bombs pointed at each other all over the world. We have an opportunity to accept the extended hand that Russia and China have offered us, that LaRouche has fought 50 years to deliver, around joining the New Silk Road, the World Land Bridge, developing an actually self-conscious galactic civilization, and really just break up all of these bad ideas that have been organizing us into empire for the past far too many years. So, with that, I went already over my time. I will leave it to, who's Ilko? Key figure in this battle towards liberating mankind from the folly of self-destruction, who was a leading scientist, somebody who most North Americans don't even know, and yet who is a national hero in Russia, a leading member of the Russian Academy of Science, as is Mr. Lyndon LaRouche himself, who is a member of the Russian Academy of Science. But this man was named Vladimir Ivanovich Vernadsky. And Vladimir Ivanovich Vernadsky is a man who is known to be the founder of a field of study called biogeochemistry, but he's much more than that. He's an individual who was born during the American Civil War in Russia, in St. Petersburg. He had died right at the end of World War II. So he lived through a very turbulent period of history. And just as we heard from Gilles, the fact that the American experience of the American Revolution or the American Civil War were not American experiences. There were certain battles that happened geographically expressing themselves in the form of the United States, but they were globally extended processes, right? The American Revolution was not supposed to be something that ended in America. It was supposed to be a process that overturned the idea of the divine right of kings around the world that was supposed to be successfully replicated in France, Poland, Germany, and beyond, into Russia and everywhere else. With Lincoln, his allies immediately were invited and brought to Japan, to Russia, to Europe, to South America, to bring that system of Hamilton, the conceptions that we've been allowing ourselves as a species governed by free will to either obey or not obey. So there's a certain reality, and if our ideas are not in harmony with that reality will come creeping up on us in the form of an unnecessary war, and the realization that we haven't been producing what we needed to produce to sustain our population, and we have a collapse, in the form of banking meltdowns where people start worshiping money, thinking that that's the source of value and power and wealth instead of something more profound and more real. And we've seen this historically, right? Where folly drives a people to obey ideas that they should otherwise know are wrong, to the point that they pay the piper. You have a collapse of civilization. You have banking collapses. You have unnecessary war. Okay, good evening, or good afternoon. I'm going to take about 25 or so minutes, maybe 30 minutes, to go through some ideas that are very, very big. And I encourage everyone to continue this discussion after the conference is over, and continue this after you leave this experience today by doing the research and a lot of the original writings that you're being introduced to.
What's your name?
My name is Matthew. Hi, everybody. As we've seen from the previous presentations, there comes points in human history where we encounter pregnant moments, moments where the ideas that organize the society into a certain direction confront reality, where reality starts pressing upon us. And the question is, do we have the wits to foresee into the future the consequences of bad ideas, wrong ideas, and change them through a process of deliberation, wisdom, courage, before our children pay the effects? And we're sitting today, as we all know, on the biggest bubble, financial bubble in history. We're sitting on the verge of a major war between NATO powers and countries that want to have a future, like Russia, China, and their allies. And this is not the first time. However, this is the first time that this has happened on such a large scale, and the first time that we've had atomic weapons peppered all over the earth. I'm going to introduce something which has been touched upon in previous presentations by looking at somebody who Mr. LaRouche has cited on many an occasion as being a